All right, so the test went pretty well for everybody. And so that's, one experiment successfully completed with everybody doing pretty well on that. The one that we need to start today is chapter 6. So the rest of the term we'll be doing chapter 6 and then chapter 9. We may have to jump a little bit into, I want to say it's chapter 7 for some of the stuff in 9, but it shouldn't be too bad. But yeah, so that's what we got going on. So today I'm going to start with chapter 6. So let's see, I want that one. Okay. All right, so this is chapter 6. And it's factoring. This is section 6.1, factoring the greatest common factor. And also in here is factoring by grouping. All right, so to start with, we're going to look at what is the greatest common factor. The GCF of a list of integers. Or in the case of algebra, terms, is the largest common factor of those terms. Okay. All right, so for your first example, you're given the three numbers 40, 56, and 96. And you're asked to find, excuse me, you're asked to find the GCF. So how does this occur? Well, I can give you my strategy, which is, as you look at 40, 56, and 90, is there a number that goes into 40, 56, and into 90? So if I take a 2 out of each of those, I'm left with a 20 here, a 28 for the 56, and 96 divided by 2 is 48. Is there a number that will still go into 20, 28, and 48? I can still take out another 2, right? And I can still take out another 2. Now, is there a number that will go into 5, 7, and 12? So at this point, there are no more common factors other than 1, right? So that means that 2 times 2 times 2 is the GCF. This works for numbers large and small. If I'm given the numbers 560, 952, and 1064, I can use this exact same method. I can start with a 2 again. It's 280, 952, 476, 532, still going to go at 2, 140, 238, 266. All of these are still all even, so I can go with a 2 again. Gives me a 70. Let's see, 238 divided by 2. I don't think that one's going to work out. That's going to be a 119, and that's going to be a 133. So I've got a 70, a 119, and a 133. I feel like these are still too big. So do you see how I've got a 70 here, and I know that that's going to be 7 times 10? So I'm going to try a 7 into 119 and into 133. So I've got, what, a 119 there? I divide that by 7, that gets a 17. And 7 works. So a 7 gives me a 10. I've got a 17 here and a 19 there. Now, is there a number that goes into 10, 17, and 19? That's, again, no more other than 1. So this 2 times 2 times 2 times 7 is the GCF. That's 56. Correct. The final form would be given as the product. Occasionally, they will ask for it in like exponential form, where you would do like a 2 to the third or 2 to the third times 7. But most of the time, they do want it as the final product. Okay? So, because this is algebra, they're not always going to be just numbers. They're going to throw letters in there too. 33c squared b, and then we'll do a 55c b squared. Now, out of both a 33 and a 55, you could take an 11. And then, since we can't take anything more from a 3 and a 5, we'll look at the letters. Here I have a C squared, and here I have a C. What could I take out of both of those? This is a C squared, and this is a C. I could take a single C out of both of those, leaving 3CB on this guy and just 5B squared on that guy. Now, since this one has a C and this one does not, I can't take a C out anymore. But this one has a B and this has a B squared. So I could take a B out. Leaving my greatest common factor to be 11CB. Yeah, I know that feeling. Okay. Was a nice yawn. 42 s to the third t squared, and then a 63 s squared t to the fourth, and then a 14 s to the fourth t to the third. If you look at the numbers, you've got a 42, a 63, and a 14. What can you pull out of all of those? Hold up. I know I can pull a 7. I'm going to do one at a time, okay? So I know I can pull a 7. That leaves me with a 6s squared t squared, a 9s squared t to the fourth, and a 2s to the fourth t cubed. I can't pull out any more numbers. A 9, a 6, and a 2 don't have any more common factors. But if I look at the s's, here I have an s squared, here I have another s squared, and here I have an s to the fourth. Oh, cubed, sorry. Thanks, Mom. All right, so here I've got an s cubed, an s squared, and an s to the fourth. So I could pull an s out of each one of these, but I could also pull a second s out of all of these. So as Ryan suggested, rather than do it twice, I might just pull out an s squared, leaving me with 6s t squared, 9t to the fourth, and 2s squared t to the third. Now, since I can't pull out any more numbers, they don't all have s's anymore, I can pull out a t, and I'm going to pull out a t squared since that's my lowest exponent. And that's going to give me a 6s, 9t squared, 2s squared t. And my greatest common factor would be 7s squared t squared. Question. Are we all good on those four examples? Okay, excellent. Then we're going to use those to factor out the greatest common factor from several problems. All right, so here we go. 5. Given 18x minus 24. What could you factor out of an 18x and a 24? If we pull a 6 out of 18x, 18 divided by 6 is 3, and I'm left with an x. And then when I pull a 6 out of minus 24, I'm left with minus 4. (18x minus 24) is the same as 6 times 3x minus 4 in factored form. I know this because if I wanted to, I could multiply back or redistribute I'd have 6 times 3x minus 6 times 4, or 18x minus 24. You would not, well, you would have a factored form, but you would not have factored out the greatest common factor. Right? Because you could still pull out a 3 if you just did a 2. All right, let's try another one. Let's factor 25 minus 10k. So with a 25 and a minus 10k, what could you take out? So if I pull a 5 out, 5 out of 25 leaves us with 5. And if I take a 5 out of a negative 10k, I'm left with a negative 2k. And that's it. I have factored out the GCF. 32x squared plus, oops, I missed one. 32x squared y to the 4th plus 16x to the 3rd y to the 3rd. I got a 32. My coefficients are a 32 and a 16. What could I pull out there? Okay. What else? Let's look at the x's then. Yep. And then we'll look at the y's. Okay. So if we do 32 divided by 4, that's going to give us an 8. x squared taking out an x squared doesn't leave any. Y to the fourth taking out a y cubed leaves us a y. 16 taken out of 4 leaves us a 4. X, y cubed taking out a y cubed. So what do you notice when I've got that factor? Yep. So I could take out another. So if you notice after you factored that you missed something, like in this case, you can just take that out front. So that's going to be now 4 times 4, x squared y cubed, 2y plus 1. So what is 4 times 4 there, Kong? Yep. Do you see how you can sort of fix or tweak an error if you missed the actual greatest? You've just got to be able to catch it here. Sometimes you will, in all honesty, and sometimes you won't. It's just kind of the way that works. Okay. All right, so 2ab cubed c minus 6a squared b squared c squared minus ab. Hello. Oh, instead of a class section. Yeah. Okay. Good. I'm glad you found it, Summer. Okay, so we've got a 2ab cubed c minus 6a squared b squared c squared minus 8. What can I take out of all of these? Well, I don't have a 2 over here. I can take a 2 out of this one and a 2 out of this one, but I don't have a 2 anywhere here. So I can't take a 2 out. Yep. All I can take out of this guy is an A and a B. And then I'm left with 2. A's gone. B squared C minus 6 A B C squared minus AB, but I'm taking both A and B out. So if I had AB and I'm taking both A and B out, that means I'm left with just 1. AB, take out AB, or AB divided by AB is going to leave you with a 1. They're all pretty much the same. We're just sort of building in difficulty, Summer, like I do. Okay. So let's try a couple that aren't, they're not difficult. It's just, I'm not sure that you might see it. So if we've got an x times x plus 5, and we're going to subtract a 3 times x plus 5. What common part or what portion is common to both of those? Yeah. For this guy, the x plus 5, or the parentheses here, is the common part of the terms. So it's actually the x plus 5 that can be pulled or factored out front. And when I pull out an x plus 5 out of each term, I'm left with x minus 3. Here I have 2y times in parentheses y plus 1 plus 7 in parentheses y plus 1. And again, we see that y plus 1 is common to both of these terms. That means that I can pull that y plus 1 up front, leaving me a second term of 2y plus 7. Or second factor, sorry, of 2y plus 7. Mm-hmm. You wouldn't solve it. We're factoring. These two? No. Oh, you mean if you were to distribute here and then FOIL on this side? Yes, you should get the same numbers. Yes. The same terms. But we're not doing that. We are factoring. Okay. All right. Oh, man. Okay. Negative a to the 5th plus 4a cubed. Yeah, that's all chapter 6 is. It's totally factoring. All right. So if we've got problem number 11, and we've got a negative a to the 5th plus 4a to the 3rd minus 6a. This one is specific because they want to point out that when you lead with a negative like this, a negative a to the 5th plus 4a cubed minus 6a, you should pull a negative out. That negative should be a part of your common factor. So a to the 5th, 4a to the 3rd, 6a. I can't pull out any common numbers, but I can pull out an a. And because this lead is negative, I should pull out a negative a. That will leave me with a to the 4th minus 4a squared plus 6. So when you're leading with a negative, you want to pull a negative out when you're factoring. That will change the signs on everything. That's left in your second factor. Here in number 12, we're also leading with a negative. Negative 12x to the third minus 8x plus 4. So I'm going to pull out a negative. Then I've got a 12 and an 8 and a 4. So I can pull out a 4. X cubed x and nothing. I don't have any x's or anything I can pull out. So this is going to leave me with 3x to the third plus 2x, 4 divided by a negative 4. Negative. Questions? Good, good. Okay, let's take it a step further. All right, the second part of this section is factoring by grouping. Factoring by grouping uses all the skills that we've just got done practicing and kicks it up just a little bit of a notch here. So here we go. Factoring by grouping is most often used when you see 4 terms, 1, 2, 3, 4. And what you want to do is look at these terms as groups of 2. As you look at the first 2 terms, 2c plus 2d, is there something that you could factor out of them? If I factor out a 2, then I would be left with 2 times c plus d. Let's look at the second pair of terms. Is there something that I could factor out of a minus 3c squared minus 3cd? Anything else? This has a c squared, that has a c, so I could pull out a c as well. And if I did that, minus 3c squared, take out a minus 3c, I'm left with a c. Minus 3cd, take out a minus 3c, I'm left with a plus c. Yes, sir. Mm-hmm. Correct. If this had been a plus 3CD, we still would have factored out a minus 3C, but that then would have been a minus. Okay? So yes, we do have to make the signs make sense. And one of the ways that I check that is to, in my head, because I've practiced, I can redistribute. Negative 3C times 3 is a negative 3C squared. Negative 3C times D would be a negative 3. So I'll do a quick back check of distribution. But yeah, there is the possibility of moving things around and getting the same answer. Some of the steps in the middle might be a little bit different, but you could move some things around and get the correct answer. Yes. I'll show you in just a second if that makes sense. Okay. So do you see how now what we have in our second step is the C plus D shows up in both of those? So I'm going to pull that C plus D out front. And then my second set of parentheses would be the 2 minus 3C. Nope, not really. I find it's best to have a habit, right? And my habit is to pull the one I'm factoring out front. So, but no, this could be switched around the other way. Okay, now, Kong, just so you can get the idea here, maybe you didn't see the 2 right away. Maybe what you did was see that you wanted to put 2C with the minus 3CD. So I'm going to put those two together. Then I'm going to do plus 2D minus 3C squared. Oh, yeah, that's right. Okay, now you could pull a C out of these first two. But then I can't pull anything out of those two. Right? So that rearrangement isn't going to work. But if I put the 2C with the minus 3C squared and the 2D minus 3CD, now I can pull out a C. And I can pull out a D. And do you see how I get the same answer as before? So it is possible to choose different pairs or partners and get the correct answer, although it's not always the ones you think right off the bat. Does that help? Okay. All right, couple more examples. 7x minus 7y plus xy minus y squared. All right. I like that the 7 pops out right away, so I'm going to keep this order. And I'm going to pull out a 7, x minus y, plus, what would you pull out of the second pairing? Pull a y out of the second pairing, then we're also left with an x minus y. This is going to come forward in both. X minus y times 7 plus y. Too fast? Too slow for anybody? Austin, you still here doing okay? All right. Okay, we'll try 15 x to the third plus 6x squared plus 8x plus 48. Right? I like the order it's in, but I mean, we could rearrange some things. Okay, what would we pull out of the first two? Leaving us with an x plus 6. And out of the second two, leaving us with the x plus 6. That x plus 6 gets pulled out front. And we're left with x squared plus 8. All right, 16, we've got x to the 6th minus ax to the 4th minus x to the 3rd plus ax. Here's one where I might rearrange, right? I might rearrange this one to put my a's together. Not saying you have to, I'm saying you could. Then out of the first two terms, I'm going to pull an x to the 3rd. That's going to leave me with an x to the 3rd minus 1. And what would we pull out of the second two? And we would want it to be a negative ax since we're leading with a negative. That's going to give us an x to the 3rd. And an ax divided by a negative ax is going to get us a minus 1 again. Or dropping pens. One of the two. You could pull an X out of all of them. Yeah. Well, this we should factor fully. So what I would do for this one is, do you see right here how I could pull an X out of this guy? It just depends upon where we're going with the practice right now. Whether or not this is okay or this one needs to get done. Today, this guy. Today, this. I don't remember if your program is making you do all that stuff right now. But the factors can be in any order. So, like for this one, you could write your answer in as x plus 6 times x squared minus 8, or you could put your answer in as x squared plus 8 over x plus 6. Both of these would be okay, because when you're dealing with the factors, the order wouldn't matter. All right? Any questions for me? Is there anything I need to clarify for you? I don't remember. Check the schedule. The updated schedule is available on Blackboard. I don't remember the date specifically. I want to say, yeah, I think it opens like next week, Thursday, and is due Monday or something like that. No, you have 2 exams left. Summer. Two tests. No cumulative final. Okay. All right. Anyone else? What's that, Summer? For me, it's a little rough. How's it going for you? Well, that's good. That's good. Same here. Same here. That's my plan for today. All right. Okay, if nobody has any other questions, this particular lesson should be available on YouTube and on Blackboard by tomorrow. So if you need to review it, you can do so. Your homework is due Wednesday at midnight, 11:59, 6.1. All righty? All right, guys. Hopefully I will see you tomorrow, same time, same place. All right, take care of yourselves. Bye bye for now.